Welcome everyone. Thank you for joining the Hydronic Heat Working Group call. This is postponed from 2 weeks ago, which is why it says October 31st there. Apparently scheduling on Halloween wasn't the greatest idea. So we can get off and moving. Next slide. Antitrust, AWHI is member-supported collaborative of professionals from across the U.S. The membership includes numerous competitors and chemistry taken to abide by federal and state antitrust laws. At these meetings, we do not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or accessory. Move along. So today was going to be a little bit of a different format. I had the pleasure of speaking with Peter about supply temperatures and contractors in Wisconsin for hydronic systems a few weeks back. And as we were thinking up an agenda for this meeting, I thought it might be great to have just an open discussion with all of the attendees here about what that looks like. So it's, I think, effectively Peter converting that interview into a big group interview, and hopefully we'll get some lively commentary. All right, next slide, please. Okay, is there anyone new to this call? If there is, please come off mute and introduce yourself, or feel free to drop it in the chat if you don't feel like speaking.
Hi, John Sigenthaler. I tried to get on a previous meeting, but for whatever reason wasn't able to, so I am new to the group.
Thank you. Yeah, we are, I think, gradually evolving and figuring out our group tech issues, but I'm glad you could make it, John.
Yep.
Hello, my name is Hadi Ramin. I'm with GTI and happy to be here. Thank you.
Welcome, Hadi.
Thanks.
This is Kelsey Zhang. I'm with Peter on this research project. Happy to see everyone.
Welcome, Kelsey. All right. We can move along then. So, for those of you that don't know, this group is convening folks who are interested, knowledgeable about air-to-water heat pumps so that we have a place for everyone to discuss. I was literally just on a hot water forum steering committee meeting where we had a chunk of time where we said, well, there should be more representation for air-to-water heat pumps in this meeting, and where is that? And there were like a few presentations, and so this is the place where we can convene the folks who know about air-to-water heat pumps and ask questions and refine our knowledge together. Next slide, please. And I think now, if there is anybody who has a upcoming, you advance to the next one too, an upcoming, a report that's coming out, any activities, projects, or programs you want to give an update on, anything that's hot off the presses, feel free to share. Yes, Chris.
Hi, good morning, everybody. I just wanted to flag a new report that just came out on Halloween from the Fraunhofer Institute in Germany. It's the Fraunhofer Institute Solar Energy Systems group. Fraunhofer's quite big, but Solar Energy Systems does a lot of interesting work. And this one is their monitoring data report of a residential air-to-water heat pumps in existing buildings. And it has, I think, long-term monitoring and energy efficiency data on, I believe it is 61 air-to-water heat pumps and another 16 ground source heat pumps. I'm not sure about the monitoring time. The problem is that it is for the domestic German audience. It's only been released in German so far. I don't know what the plans are for releasing it in English, but I'd be happy to do a summary on it in a future meeting once I've had a chance to work through it with my bad German, or maybe we can get something from somebody from Fraunhofer to speak to it. They may be willing to do that.
Yeah, that would be great. I mean, the first one would be great. The second one would probably be much better.
Yes.
Though I appreciate the volunteering for your German. Do you have a link to that you could drop in the chat?
Yes, I believe so. I'll let me find that and I'll do that as we move on.
Great, thank you. Anybody else have anything new upcoming? Okay, I think we are sort of through conference season, the fall conference season. And probably a bunch of folks are presenting in the early spring conference season, but we'll cross that bridge when we come to it. All right, let's move ahead then. I think I'm passing it to Peter for the next part, and Kelsey.
It looks that way indeed, yeah. All right, thank you, John, both for kicking off the meeting and for that introduction. And I'll stop sharing now because, as John implied, we're going to have a conversation. So there aren't really PowerPoint presentation slides. And if we don't share, then we can see each other's faces as we're talking instead of seeing some, boilerplate slide. So as John mentioned, Kelsey and I are working on a Department of Energy funded technical research project, really trying to understand the industry's temperature requirements for residential hydronic heating system. What temperature do you need to provide at the heat emitters? Why do you need to provide that temperature? What are people doing out in the field? These sorts of questions. And as John implied, or as John directly stated, we've had conversations with a couple of you now, so sorry, John Siegenthaler, that this morning's going to be a little repetitive for you. But since there's a lot of people in here that are experts on this topic, we thought it'd be great to have an open discussion, see what people think, and get down some notes that we can share with the Department of Energy. So with that, I'd really like this to be kind of a flowing conversation. I've got a bunch of questions we can use to prompt the conversation, but if y'all keep running with stuff, we can just let it go and take some good notes. But perhaps a good first question to kick it off with is just understanding everybody's experience here. How many of you are directly working with hydronic heating systems? If you're working with hydronic heating systems, how many of them use boilers versus heat pumps, radiant surfaces versus radiators or baseboards, etc.? And also, if you're working with them, where? Are these in certain parts of the country? Are these in certain types of buildings, etc.?
I can start off. We have a field study of 5 heat pumps in 4 buildings in Wisconsin, and those are all currently running. They're all inflow radiant. Some of them have cooling from either an air handler or fan coil units, and then we also have a partial displacement multifamily boiler project that is more of a market assessment for ComEd. But I am out in the field occasionally touching systems, just not that many.
All right. Thank you very much, John. So we've got that put in our notes. Anybody else feeling brave enough to jump in?
Oh, what the heck?
Yeah.
Go ahead.
Yeah, one of the things I'm working with is with Ridgeline Analytics and GridWorks, and we were talking about it earlier this week. They're doing some pilot programs or pilot installations up in Millinocket, Maine, and they've tied in air to water, but these are high temperature air to water systems. They are cascading heat pumps, so it's an R410A outdoor unit that feeds refrigerant to an R134 indoor heat pump. So they can get a tremendous temperature lift. They're producing water in excess of 180 degrees Fahrenheit at times. That's going into thermal storage, or it can go directly to the load. They're retrofitting, I think at this point, they've got 6 houses up in that area. The work's being funded through Efficiency Maine. and the results so far have been very impressive. So they're continuing. It's George Baker. Some of you may be familiar with him, George Baker from GridWorks, and Jessica Millar. They're they're developing some algorithms that would allow the simulation of this system to work based on a 48-hour advanced electrical pricing structure. So if you know the pricing 48 hours in advance, how would you optimize operation of the heat pump and storage? And I've been impressed by what they're doing. I helped them design the piping and the valving for that system. And looking forward to another heating season where they're going to get some more data.
What's the on these cascading systems? What is the all-in COP?
I haven't seen that data, John. I don't think it's extraordinarily high. When you've got a temperature lift from 0 degrees outside to 180 inside. I'm sure George and Jessica have that data. And, quite honestly, I don't think that a cascading heat pump like that is going to be mainstream enough going into the future. I would see an R290 heat pump, a single refrigeration cycle heat pump being used for that. And I do think that could probably get some better COPs on there compared to what they're doing now. But the projects they're working with, they've got a system from LG, and I think one of the other systems is from Samsung. And these heat pumps were built for high temperature domestic water heating. And they were never really built for space heating applications, although they can be used for space heating. I don't know what the COPs are. I doubt that they're even up to 2 when they're going to that much of a temperature lift.
Yeah, so a couple comments. I have talked to George and Jessica about that system a lot. And with the cascading system, they're typically seeing COP of around 1.5 throughout the entirety of the heating season, which is not great. The cascading system also costs an extra roughly $5,000 to $10,000 to get installed compared to a single heat pump going to 140. They also, sorry, I'm getting over a cold, so that's going to happen from time to time. They also estimate that if they had a single heat pump going to 140, it would bump the COP up to about 2.5. So there's a lot of reason to try to avoid these problems. The second comment I had is, Charles McCracken, I saw your mouth moving earlier, but you were on mute. So I have a sneaky suspicion you were trying to jump in and it wasn't working out.
Yeah. Hi, I'm Charlie McCracken, work in the Rhode Island Heating and Cooling Program for Clear Result. We did a case study this past summer, and we didn't see any water temperatures higher than about 100 and 140 on air-to-water heat pumps. And that'll work in a fan coil, that'll work in a radiant floor, but the efficiencies would not work very well for cooling. You'd probably get a lot of condensation if you were to put any of those lower water temperatures, the low side water temperatures into a floor. But John knows more about that than I do, so I decided to shut up.
All right. So you mentioned that the efficiencies would not work well for cooling, and then talked about condensation. Is condensation really the issue there, or was there something else you were also alluding to? You're muted again.
Well, in winter, radiant floors don't want low water. You're not going to be able to cool a house with a radiant floor, from my personal opinion, just because you might get condensation on the floors. That's my thought, if that was your only heat distribution metric.
Okay, thank you. All right, Chris, it seemed like you were trying to jump in a few minutes ago too. Want to take another chance or take another try?
Sure. We've got and this is kind of a homemade research project, two staff members who are one is already up and running, the other is being installed now. Hydronic heating systems in their homes based on the Sanko air-to-water heat pump. The first one that's already up and operating is in the San Francisco Bay Area, 3,000, 4,000 degree day temperature area. And the main focus there is on the load shifting capability. It's using, some fairly sizable hot water storage tanks, but also remote grid connection to allow, in that particular case, to take advantage of the time of use rate. And then the other house is mine in 7,000 degree day environment in northern Vermont. And in this case, it's the first house is using hot water to feed a fan coil and for hot air distribution. I have a more sort of traditional Vermont hydronic system with baseboard heat, and this is part of a pilot run by Efficiency Vermont and Green Mountain Power. So it's both looking to see whether the technology can provide the necessary heat on the design day temperature, which is -12 around here, and then also whether we can get significant demand response services out of it at the other times of the year.
Great, thank you. So what are people using for storage in those two systems? Is it the same storage tank that comes with Sanko, or are you adding additional storage tanks?
In both cases, it's the Sanko storage tank. In the first one, I think it's a 112-gallon tank, and in mine, it's two 86-gallon tanks.
Okay. And then in the northern Vermont site where you've got the baseboards, what temperature of water are you expecting the Sanko 2 heat pump to be able to provide? And what temperature of water do you think the baseboards need? You sound a little uncertain about whether or not it's going to be hot enough.
Yeah, well, I think that's the challenge, and we're planning on 140, and that's the outgoing temperature. This one actually will have two Sanko units and two storage tanks, and it's outgoing temperature of 140, which will come back at around 90 is what we estimate, nothing else, but we are actually going to run it through a fan coil unit because the house has it has mechanical ventilation. So it doesn't have a hot air distribution system, but it has mechanical ventilation, and we can use that to distribute a limited amount of hot air and bring that return temperature down to 70.
Okay, so that's a little extra backup heating that you could rely on if the 140 at the fan coils is inadequate. Is that the thought?
Yeah, I mean, I wouldn't call it backup. This is going to be part of the regular operation, daily operation of the system. The backup is a tankless electric water heater that's being installed also for that just in case situation where it doesn't do the trick on the coldest day of the year.
Okay, cool.
Hopefully we'll never have to use that.
Hopefully you'll never have to use it, but if you do, it's good to have it, right?
Yes, indeed.
Okay. So how common would you say that design is of having the fan coils or I'm sorry, you had baseboards, not fan coils, sorry. How common would you say that design of having baseboards with additional air distribution for ventilation is?
Yeah, so I would say not common, but also not strange in here. So some kind of mechanical ventilation has been coded in Vermont for, this house is 20 years old, and at the time that we built it, it was common, but people often will do simple or used to do simpler mechanical ventilations, and it's just because the level of air tightness is very high. So there's generally tends to be some kind of a mechanical ventilation required, but a lot of times that's just exterior ventilation in bathrooms, you know. Yeah, I wish I had a better answer for you than that, like what percentage of homes built since, the turn of the century would be, but I don't know what that is offhand. But it is pretty common.
Okay.
Sorry, can you maybe give me a little more detail on exactly what is happening with that mechanical ventilation and pulling BTUs? Did you install a coil?
Well, that's on the job list for next week. So what I have now is a HRV that pulls
Mhm.
stale air from bathrooms and then brings fresh air into 2 points in the house. And what will happen is that the fan coil unit will be installed in the fresh air feed.
I see. Okay. That's weird. But interesting. Do people ever do that for like cooling?
Well, generally not, because for cooling the air, it's not enough.
Mhm.
It's not enough distribution, and also it tends to be not always high up on the wall, or it's not positioned correctly. The other thing you have to remember is this is a 400 cooling degree day environment, so
Yeah.
it's not a lot of cooling.
Yeah. I was just
Yeah,
thinking about the strategy of using the ERV and putting a coil.
yeah.
I hadn't done
I can
that.
comment on a system we did about 3 years ago. It has an air water heat pump. It has a 3-ton rated air handler with a chill water coil. So there's a condensate drain on that. And we tied the HRV into the return air side of the air handler. The air handler, when it runs on cooling, 3 tons, it's running at about, I believe it's around 950 to 1,000 CFM, which is a typical CFM per ton flow rate for an air handler. But it has an ECM motor, and we were able to run that motor when it's in ventilation only mode. In other words, 12 months a year, basically, ventilation only. We can bring that blower down to about 150 CFM. So we're reducing power input, and we're injecting the fresh air, leaving the HRV, the preheated air coming in. That goes right into the return side of the air handler. And then the blower in the air handler is basically running at about the same flow rate. So that goes out through a ducted system. The ducts are all within the thermal envelope of the building. And it's worked well. And that way we're basically using the ducting that we put in place primarily for the cooling to distribute the fresh air as well. So we don't have redundancy with, for example, the 2-inch flex ducting that some HRVs work with if it's a ventilation only system. And I think that's one thing that can keep the costs down. And also in the hydronics market, one of the things that has always, well, 2 things that have been missing: cooling. So that's a big deal, bringing heat pumps into the market, air to water or water to water geo that can do chill water cooling. But ventilation has always been I'll say it's an area of HVAC that a traditional plumbing and heating contractor doesn't really work with much. So I'm trying to encourage them to look at hydronic-based systems that also have a ducted system with an air handler for cooling, and then learn how to do HRV work. So now they can provide a complete solution. They could do space heating, cooling, domestic water heating, and ventilation with an HRV. So you have single source responsibility from the contractor, which is good with a homeowner, rather than have one contractor that's doing, if you will, the wet side of the system and another contractor doing the cooling or doing, ductless mini splits or whatever. So that's an approach. And we like the single air handler for chill water cooling rather than doing console units throughout the house. You can do the console units, companies like Myson, and there's some others that make some nice contemporary looking fan coils that have drip pans in them. They run in a range of about $1,000 a piece. And the downside of those is that for every one you put in, you have to have insulated supply and return piping because you are conveying chill water. You have to have a condensate drain provision, either outside or into a, into the waste system of the house. And you have to have electrical power. So there's a lot of infrastructure to support multiple console fan coils. The other downside is that these coils, any coil that's running in a cooling mode is going to get some, I don't want to call this biological activity on it. And those coils have to be cleaned. So with a console unit, just like with a ductless mini split, you're doing the cleaning at each one of those units, and you're doing it in the living space of the building. And you've probably seen companies like WeCleanHeatPumps.com. It's a franchise, and they put a clear plastic garbage bag under the wall-mounted units for mini splits, and they spray down the coil, and all the drippings go down into the bag. But keep in mind that's being done over somebody's sofa or piano or whatever. And with a single air handler, you can put that in a mechanical space, and you have one point of service for the filter, one point of service for the coil, and one condensate drain. So we tend to do systems where we can do multi-zone heating and single zone cooling. And I say that in the context of 1,500 to maybe 2,500, 3,000 square foot homes. You get up into 10,000 square foot house, you're going to need multiple zones, multiple air handlers. But for the average Joe, the average, say, 2,000 square foot house, that single zone cooling, it's definitely less expensive to install compared to doing the console units, and you can bring the ventilation air into the same ducting system. So there's some synergy there in terms of air handling in the system.
Actually, this is a general question for when there is cooling. I really want to have an air to water heat pump cooling discussion, but couldn't you run the system on like sanitize and pump 135 degree water through the fan coil units and run them for a little bit to, it wouldn't eliminate the need for cleaning, but it would probably, delay it significantly compared to doing just cold water all the time.
Honestly, I don't know, John. It's an idea. It might help. I'm not a biologist, so I don't know how the bugs would react to that. You might kill some of them, but maybe some of them would be encouraged by that. I don't know.
Yeah, maybe.
I don't know anybody's doing that. I mean, there are sterilization cycles on domestic water research systems that are used for, anti-Legionella. But typically we spec, a minimum once a year filter replacement and coil cleaning.
Yeah, I would say for Legionella specifically, 140 degrees will have a very strong anti-biological effect, I would say.
Yeah.
I don't know what other bugs might be living in a cooling system, so don't take my comment any further than Legionella.
Yeah, and you've got the drip pan and the trap that should be cleaned out once a year too. But you're going to get some mold, some slime growing in that drainage system, and once a year at the end of the cooling season, basically you clean it and it's done, ready for the next year.
Okay, so we've gotten a lot of input from a couple people here. Is there anybody else that would like to jump in and talk about their experience with hydronic systems or give an intro to it?
Oh, Peter, I forgot to say one. I dropped an important detail of the two systems that I mentioned. Both of them use the Harvest Thermal pod.
Got it. Yeah, so you're part of research experiments helping them achieve their visions of moving to New England, huh?
Right.
Good. It's good work. Oh, yeah, and one question I meant to ask you. You were talking about the Efficiency Vermont and Green Mountain Power study. It sounds like it's too early for this, but are there any publicly available documents, data sets, reports, etc. from that one?
It's too early.
Yeah, it's too early. Okay, fair enough. Well, we'll just have to follow up when the time is right. All right. So next question I had, what do contractors think? We've got a number of people here talking about fairly innovative heating systems, including in northern Vermont. How do contractors respond to these systems? Do they have certain expectations? Are these systems meeting them or not? And so on.
Well, my experience with contractors is many of them are stuck on rules of thumb. If it's a baseboard, they think 180 automatically. And they don't really investigate what could be done with lower water temperatures. I can easily imagine a situation where a contractor is asked by a homeowner to evaluate an existing system for an air-to-water heat pump. They walk in, they see baseboard, and it's a hard stop at that point. And they haven't really, analyzed it. Again, we've done simulations with NYSERDA, a program we developed for NYSERDA, and even baseboard that needs 180 at design load in a cold climate like Plattsburgh, New York. It's about an 8,000 degree day climate. Excuse me. When you bring outdoor reset into the controls, in other words, you're reducing the water temperature as it gets warmer outside, you're getting higher and higher amounts of time when the water temperature requirements of that distribution system are within the range of the heat pump. The simulations we've done up there, that was based on an R410A air-to-water unit. And during the simulation, we limited the water temperature to 130 degrees. Any heat load over 130 had to be met by some other auxiliary system. And we were still covering upwards of 85 to 90% of that seasonal space heating energy without modifying the baseboard system. And, I think we were talking about it earlier this week, when a contractor looks at, do I want to go upstairs and start, moving baseboards around or adding other emitters to the system? Contractors are probably more reluctant to do that, and the homeowners are also more reluctant because, obviously that's going to affect the aesthetics of the space. They would rather try to deal with something in the mechanical room than trying to modify the system. For example, improving the thermal envelope of the building can bring the water temperature requirements of an existing thin tube system down substantially. Well, and you can run numbers on this, but you can bring it down into the range where today with R32 and R454B heat pumps, I would say you could design systems in cold climates that could cover upwards of 90% of the load, even with baseboard. And Peter, we were talking about this earlier this week. I didn't used to think that way. I used to think baseboard, you're really kind of out of the temperature range. But again, doing things like improving the thermal envelope, and there are possibilities for adding heat emitters in spaces. One of the things that I encourage contractors to do when they go in and look at a project is to ask those owners, are there cold spots? Are there areas where you're uncomfortable? Instead of just saying we're going to either replace the boiler with a heat pump or add a heat pump to the boiler, what else in the system is perhaps a problem? Because let's deal with that. And there may be opportunities that come out of that to, it might be as simple as, we would put a towel warmer in the bathroom. And that's going to add surface area to the distribution system. That's going to help bring water temperature down. Not a lot, but that type of scenario where you look at possibilities for not only shifting your generating source of the heat, but improving the comfort in the building. And I think our industry, the hydronics industry as a whole, we tend to focus more on the hardware and the energy and not really think about the comfort as much, or try to develop our projects around the goal of improving the comfort on the part of the homeowners. So yeah, there's definitely opportunities to bring water temperatures down and bring those temperatures within the realm of the heat pump, not necessarily for 100% of the load, but for the majority of that seasonal space heating energy using outdoor reset as a main control function. And many of the air to water systems today, they have that built in. They can monitor water temperature and control it based on outdoor reset.
Great. Thank you very much for all that, John. Charles, you looked like you were getting. Oh, Hugh wants to jump in too. All right.
Sure. I just wanted to reinforcing kind of what John was saying. So in my personal house, I installed a water to water ground source system. It took the place of the boiler. So I kept the hot water baseboard and I used that. And we wanted to have cooling as well, obviously. So we installed an air handler. And we allowed the air handler to be second stage heating. We didn't buy a fancy water to water heat pump. It was a pretty ordinary one. So we started out at a pretty low supply temperature, 115 degrees. And I always thought I would have to increase it. And I never have. So it's been 5 or 6 years. And so with the baseboards, I'm able to heat my house down to about 35 degrees outdoors. And then the air handler starts to come on at second stage. So I think you can get a lot of heat out of baseboards at low temperature. And the other thing, so I was involved in an NYSERDA study of 5 homes, and Tatum was involved. And the original intent was that everybody was going to install air source heat pump and do something to install an air handler, install radiators, and no one ever did. So I think John's right. People are very, that we always talk about there'll be more heat emitters and all that stuff. But in practice, I think there's lots of resistance, probably because people don't like how it looks and probably because the price tag is high.
Okay. How about contractors, Hugh? And when you were installing that 115F system with a baseboard, were contractors excited to do it, or did you have to interview a couple hundred?
No, they so I think this contractor actually thought, so that there's a fancier heat pump that can make hotter water. It costs more. I think my contractor thought, and I think he was right, that it's more that if you're installing the air handler anyway, you can just make it slightly bigger, and then you don't need 135 degree water, right? So if I had been stingy on the air, and so the air handler was oversized. It's a nominal 5-ton air handler, but the other thing I always thought, so it's always been on low speed for 5 years, and I've never had to bump up the speed. So I basically overspent on the air handler, did not overspend on the heat pump. And I think that was a good trade-off. And I think the contractor thought that was the better way to go too.
I have a question related to this. It was my experience in our study that the ground source heat pump contractors are significantly better at understanding the needs of a home, probably because they design fancy systems for people all the time, and they're like, yeah, put some distribution here, some there, blowers, whatever you need. But that is very different than the boiler folks who are going to come into it maybe not prepared to think through it in that way.
Yeah, I think they have the experience with what do people want? They want to tack on cooling, and they have experience with that. And really the only way to do that is an air handler. And so I think you're right. The geothermal guys are really the ones that know about hydronic systems, because water-to-water heat pumps in upstate New York are relatively common. It's maybe 10% of the geothermal market, maybe more.
Mhm. Yeah, and the geo contractors, they're going to have more experience with controls. I think one of the biggest challenges in hydronics has been controls. In a rural, I live in rural upstate New York, and we've got, for example, fuel oil suppliers that have technicians, and they can come in and they can service an oil burn. They can put a nozzle in, change a filter, do a quick efficiency check. When they look at some of the controls on a sophisticated system, honestly, most of them are quite intimidated by that. So getting these traditional, what I'll call plumbing and heating people that are very comfortable around piping, getting them over into air to water in particular, or geo. I mean, the geo system, the internals of these heat pumps are similar. Lots of sensors, lots of printed circuit boards. It's more intimidating than a Beckett oil burner would be. So getting them comfortable with the control side is a challenge, and has been a challenge for a long time in this industry. We find contractors in all areas of the country. Some of them are very top shelf people. They're totally into these systems. They see it as a very creative outlet. They'll design very nice, elegant control systems. And then the other side of that spectrum is some contractors won't even touch electricity, even low voltage electricity. They'll get an electrician to come in to do the control wiring. So getting them comfortable around, fairly sophisticated product like an air to water heat pump, there's an inherent mistrust. And for whatever reason, it's there. They look at the internals of a heat pump, and then they look at a Beckett oil burner. And there's a big spectrum of sophistication there. So I think where the industry will go, I think you're going to see some early adopters that will be out there to prove the concept works. And there's going to be mistakes. There's definitely going to be mistakes made. One of the things that actually concerns me the most with air to water going into that market, and on the cooling side, getting the contractors to understand the importance and the methods and materials for insulating the piping, because you cannot mess that up and have a long-term well-performing system. I can send all kinds of photos of corroded circulators and valve handles that are completely rusted. The systems are still functioning, but the contractor just simply didn't understand that these things are going to be way below the dew point, and they're going to have condensation on them whenever that chill water cooling is running. So, for example, we're going to encourage them to use pre-insulated PEX to go between the mechanical room and the air handler. So instead of trying to run copper pipe and then put 6-foot pieces of insulation on it, glue the joints together properly, they can buy pre-insulated PEX, and they can run that through, similar to running electrical cable. And that helps them, get the proper insulation on the piping. So the training for air to water, or for that matter for geo, if they're going to do hydronic based cooling, they really have to understand the importance of that insulation.
Right. Charles, you've been waiting very patiently. Want to jump in?
Sure. We run the Rhode Island Heating and Cooling Program, and we've got a whole bunch of contractors, probably 70 contractors that work in our rebate program. And we are, like everybody else, transitioning to A2L refrigerants. And one of the things that relates to something that John just said is that the best thing I can see about the A2L refrigerants, which are mildly flammable, is that all of the flame sensing equipment is going to be a factory plug. It's not going to be field fabricated wiring. If something fails, you got a plug-in connector from the brand. You buy the right product, and you're not asking a technician to wire low voltage. because that's just going to be a horror show, to be polite. The other thing that we mention to contractors at all times is when we talk about using, design temperatures, 90% of the heating load in Rhode Island is 17 degrees or warmer. And that means that the times that it's going to be really cold, you're probably sleeping. So sizing to the cooling load, or 130% of the cooling load, when any kind of a heat pump installation is going to keep the costs down and going to leave your existing equipment as the backup product line. And that just seems that people, as has been mentioned, constantly use rules of thumb and oversize, and you're better off improving the shell before you change the equipment than doing anything else. It's the cheapest money you can buy. I unloaded probably 25 tractor trailer loads of cellulose in my life as a solar and insulation contractor in the 80s. And it's the cheapest thing you can do before you start spending money on your equipment.
So when you talk about equipment, in this case, do you mean specifically the heat emitters or also the central plant?
All of it. I mean, if you don't need as much heat, then the insert, well, in the Northeast, we won the Civil War, and we built a whole bunch of steam-powered houses with coal. And what we have in the Northeast is wet heat. And we have Northeast wet heat when the transition would be better suited to ducted. And so installing a ducted system is going to be an extra cost, but I think it's definitely the way to distribute cool air and keep your condensation and your moisture problems localized. This isn't a design class, John does that, but I've done this work. So what we do is try to get contractors not to overthink it, and size things correctly. You can spend a lot of money trying to do 100% of the load with a refrigeration-based system.
Yeah, talking about sizing too, you look at a boiler in houses, especially a boiler that's been there for maybe, cast iron boilers, it could have been there for 30 years and still functional. And some of these projects, they get envelope upgrades. So the load goes down, but, so relative to the boiler output, the boiler becomes progressively more oversized. And contractors inherently will try to oversize boilers because, first of all, they may not do any type of heat load estimate, or they might do it very crudely. They might say 40 BTUs per hour per square foot, and they'll put 150,000 BTU per hour boiler in a 2,000 square foot house. So it's oversized, and that mentality going into air to water heat pumps is a challenge, because you actually can take, for example, a nominal 4-ton air to water heat pump and put it in a house with a 3-ton load. You might say, well, gee, that's grossly oversized, but the difference is the capacity of that heat pump is highly variable based on air temperature and based on water temperature, whereas the boiler is more or less, a standard cast iron boiler it's on or off at a certain rating. So really, sizing, in my opinion, sizing on air to water heat pumps ideally would be based on a simulation model of some sort, something that a contractor could access. And it would take into account the load of the building, certainly the design load of the building. It would take into account outdoor reset. It would take into account what is the supply water temperature at design load. And it would take into account the performance characteristics of the heat pump, COP curves and the capacity curves, and weather data for that location. So basically, it runs the system through an entire heating season based on bin temperature data, and it integrates out what those net effects are. The seasonal COP, the percent of the load that is met by the heat pump. And, we built that around an Excel spreadsheet. And it's more, our version of it right now, I would characterize it more as a research tool. But I would love to see more of the heat pump suppliers or perhaps other organizations generate these sizing simulation tools that could be, for example, a contractor could pick a specific make and model of heat pump, and knowing something about the water supply temperature requirements of the building, they could run this and they could get performance information, make decisions based on that. Even economic calculations could be done. As opposed to, all right, let's say I've run a manual J calculation and I've got a house with 40,000 BTU per hour load. What do I go try to find a heat pump that's 40,000 BTUs per hour? Do I go bigger than that? That would be the typical American mentality. Yep, if it's 40,000, put a 60,000 in there. And that could work, especially if it's a modulating heat pump and if there's a buffer tank in the system. So, that's one thing I think that's lacking in our industry right now is availability of software that is accessible at a contractor level that can be used to size this equipment. And essentially, I call it the what if. What if I put this heat pump in this house, in this climate, with this heating distribution system? Here's what I'm going to get. And there's no necessarily perfect answer. You might try 2 or 3 different capacity ranges on product. You might be able to say, all right, suppose I reduce my design heating load by 20%, and I put that into the software and I run it again and see what the net effect is. So that ideally, I'm encouraging manufacturers of air to water to do that. Some of them have developed some tools. They aren't really polished at this point. They're more for internal work. But our industry, the air to water heat pump industry, the hydronics industry, could use tools like that would help contractors size these products up. They're going to be different from sizing boilers and different from sizing air-to-air heat pumps too, because hydronics brings in storage, especially with buffer tanks or high mass slab systems. You have the ability to store heat way beyond what you could do with any type of all air system. And we don't really have tools that, there are research tools like Trinsis models and so forth. That's just not realistic as a tool for contractors to work with.
So I'm curious, have you tried sharing your version of the tools with contractors at this point?
We showed it to contractors. We haven't really distributed it anyway, but we've demonstrated it to, actually I've shown it to some manufacturers as well. And, it was developed, as I say, under a NYSERDA program, but taking those algorithms and building it into a more universal tool. And actually, one of the things that takes the longest time in this tool is taking the manufacturer's performance curves. And they used to be nice, simple curves. You could fit equations to them fairly simply. But now with inverter compressors, you have these operating envelopes, and you have very different performance characteristics. But you have to quantify that, because that is how the weather data and the load data on the building is going to have to drive that heat pump model. So at any given operating condition, you need to know what is that COP and what is that heating capacity. But, and again, I don't know if there's any DOE projects looking at something like that, but I would love to see, some funding to do something like that.
Yeah, so I would say, at the time that DOE started this project, they were very interested in kind of a survey, understanding what's going on out there, understanding what the typical problems are, understanding what the potential solutions are so that we could make some recommendations about what future projects would be. Which means that as of summer 2024, your comment there is exactly what they were looking for. As of November 2025, I'm not entirely sure that's true anymore, if you know what I mean. We're running real short on time, so I'll quick pass it over to Charles before we wrap up and close.
Well, one thing about sizing equipment, I know NEEP is actively in the business, Tara's here, of designing and sizing equipment. But the other thing that we ran into in our heat pump study this summer is that typically there's like 2 models of water-to-air heat pumps or air-to-water heat pumps. And the one of the ones that we saw had 2-ton and 5-ton options. So I mean, and I can't remember what the NTI system had, but usually it's not a complete path. It's just you're going to be storing the water and only using as much as you need to.
Yep. Usually like you say, 2 nominal capacities. What's common is about either 2.5 and 3, and then jumping up to either 4.5 or 5.
Right. Well, yeah, that's basically what we saw. 2 sizes right now. With LG, with anyway. And people were very happy, but it wasn't cheap. It was going to be $40,000 to $80,000 depending on what you're doing, which is really kind of the end of the world as far as I'm concerned.
Well, some of these projects are being priced very high. We're finding the same thing, Charles.
Hey everyone, I need to step in because I want to make sure I get the housekeeping notes out to everybody before people have to sign off for their next meeting. Awesome discussion. I took a lot of notes as well. I'm going to be looking for speakers to talk about upcoming standards. I am interested in revisiting that, AHRI, maybe CEE. So if there's anybody that comes to mind, let me know. I am going to also be sending out the listserv like auto sign up email, and it's a little confusing, but reply to it, and it has a code that you have to reply to it with. It like lists these instructions in the email, and then you should be signed up for the listserv. We'll see how it goes. It's kind of janky, but hopefully it works. And then the next presentation is going to be from Steve Nadell, who's going to talk about kind of a national top-down picture of air-to-water heat pumps in the US, which should be interesting, and maybe we'll talk about costs then too as well. Otherwise, please send me any ideas for sessions that you have. It sounds like the reviewing the Fraunhofer paper might be a great session as well, and I'll look around to see if maybe we can get a Fraunhofer speaker who is bilingual to present to us. Thanks everyone. We are at time. Great discussion. Thank you, Peter, for leading that, and Kelsey as well for probably taking better notes than I did.
And better notes than I did too. Yeah, yeah. I'd like to echo John's comment. Thank you, everybody. That was a very helpful conversation, and we can follow up via email if you want to continue talking.
Thank you. Have a great weekend.